So today we are going to learn about graph theory, but mainly we're going to learn about what are vertices and edges, what's a degree of a vertices, and the different graphs, how to differentiate different graphs, and faces. Oh, and trees. I forgot. So, let's start. What do we mean by vertices? Vertices are simply a dot on a graph. As we've seen on a lot of graphs, we would see some point here of x and y. But vertices simply just equals to a dot without a graph. Pretend that this doesn't exist. It's literally just a dot. That's the wrong pen. A dot. Or a dot here. Or a dot here. It can be anywhere because it's not on a graph. What do we mean by edges? Edges equals to a line. A line that's connected by two vertices. Now, vertices connects edges. There can be multiple edges connected to a vertice. Or, not a vertice, vertex. The singular term for vertices is called a vertex. We've seen that before, a vertex. We heard of that before. A vertex also means that's the wrong pen. A point, the highest point on a graph. Like here, this is a vertex, but it's not what we mean. Vertex here has a different meaning. Now, here is a graph. It could look something like this. This is a graph. This is what we call graph in graph theory. As you can see, we don't have the x and y coordinates like we do in, say, algebra, not algebra, geometry, or whatever you need for graphs. This doesn't require a graph. It doesn't require any x and y's. It just requires vertices and edges. So, just a reminder, this is a vertices. These are vertices. That's a vertex. This is an edge, which is a line. Now, let's move on. What are the degrees of a graph? Here. Degrees. Is that how you spell degree? Yes. Think of degrees as the number of edges connected to a vertex. So, say, let's look at this example. How many edges is connected to this vertex? So this would be 1, 2, and 3. What does that mean? That means the degree of this vertex is 3. And we look over here. How many edges is connected to this vertex? 1. So, the degree of this vertex is 1. And it goes the same for here and here. That's what we mean by when we say how many degrees are there for each vertex. We would say this vertex has a degree of 3, and this one has a degree of 1. This one has a degree of 1, and this one also has a degree of 1. Now, these are basic terms that we need to understand. It's an introduction to graph theory. We have to learn about vertices and edges. Here, I'll draw a set of different graphs. Say, this is a graph. This is also a graph. here is another graph. These are all graphs. Now, I want you to take a look at them and tell me if they're different or similar. Because they all look different. They all look different. But I can tell you right now, spoilers alert, that these two are the same and these two are the same. Why is that? We can start the easier way. Let's take a look at this graph. If you were to stretch this outwards to here and upward this one to here, we would get the same exact graph. They are the same thing because, well, you can stretch one into the other without removing an edge, or without cutting off an edge, or removing a vertex, or anything like that. You're not moving them, you're simply squishing them around. Now, how do you define that? We can also define this by using what we just learned, the degree of a graph. Let's label the degree of each vertex. So, how many edges are connected to a vertex? So this one has 2. This one has 2. And this one has 2. This one has 2. And that one has 2. What does this mean? So this, how many edges are connected to this vertex? 2. How many edges are connected to this vertex? 2. And they're all 2 because they all each have 2 edges connected to each vertex. What about this one? Even though they look a bit different, let's test. 2 edges are connected to this, 2 edges are connected to that, and so on. They all have 2 edges connected to each other. This means that each vertex also has a degree of 2. That's cool, isn't it? So, there are 5 vertices. 1, 2, 3, 4, 5. Note that this is not the degree, this is how many vertices there are. And there are 5 edges. 1, 2, 3, 4, 5. There are 5 edges, 5 vertices. Edges equals 5. The same goes for here. There are, again, 5 vertices and 5 edges. And we know that each vertex has a degree of 2. That's why these two are the same. Because they have the same amount of vertices, the same amount of edges, and the same amount of degrees. The degrees are the same. Take a look at this one. I want you to pause this video and see if you could do this yourself, and tell me if they're the same. So, I'm assuming you paused it, and now you're coming back to it. I don't know how long to wait for this, but let's try to do this. What degree is this vertex? 1, 2, 2, 1. And here we have 1, 2, 2, 1. So we know that the vertices here is, there are 4 vertices, 1, 2, 3 edges. And here we also have 4 vertices and 3 edges. So now we know that they're the same graph. Why? Because 1 is connected to 2, 2 is connected to a 2, and 2 is connected to another 1. Same goes for here. vertex with a degree of 1 is connected to a vertex with a degree of 2, and that vertex of a degree of 2 is connected to a vertex of a degree of 2, and that vertex of degree of 2 is connected to a vertex with a degree of 1. So they are the same. These two are equal to each other. Now, that's how you find different graphs. Of course, this takes more practice. And there, I will give you more trick questions. Say, let's do another example. Here I will draw this, which has, actually, I will label them later. And then I will draw this. Now, you can pause this and try to find if they're the same. Okay, now let's do this. We can first start by, again, counting out how much vertices there are and how many edges there are. So there are 1, 2, 3, 4, 5, 6 vertices, and there are 1, 2, 3, 4, 5 edges. 5 edges. Same, let's go see here. 1, 2, 3, 4, 5, 6 vertices. 1, 2, 3, 4, 5 edges. So that looks good so far. Looks like they're equal so far. Now, let's start by writing down the degrees again. This has a degree of 1 edge connected to it, 3 edge connected to it, 2, 2, 1, and 1. Here, 3, 2, 1, 2, 1, 1. Now, here's where it gets tricky, because if you look at the numbers of degrees that we wrote, they all have the same. But I'm going to tell you right now, they are actually different graphs. Why is that? Well, the simple answer is you can't say, take this graph and mush it into this graph. It's not possible. You have to remove an edge, break them, and retape them to get the new graph. If you can't do that, because that will change the graph and you will break the rule. So, why are these two different? Let's draw another graph here. Not a graph, but say we start with the point 3. We see that 3 is connected to a 1 and a 2. And this 2 is connected to a 2. And that 2 is connected to a 1. And the 3 is connected to, the 3 is connected to 2 1s. And 1, 2. This is important, I promise. Now let's start with 3 again. 3 is connected to a 2, 1, and 2. And that 2, this 2, is connected to a 1. This 2 is connected to a 1. And that 1 is just 1. Take a look at the difference. This cannot be the same graph because 3 is connected to 2 2's here and 1 1 here, while the degree of 3 here is connected to 2 1 here and 1 2 here. They're different. They have to connect by the same thing. Like here, 1 is connected to a 2, 2 is connected to a 2, 2 is connected to a 1 again. Same goes for here, 1 is connected to a 2, 2 is connected to a 2, and 2 is connected to a 1 here. you have to stay in the same order. You have to stay in the same pattern. That's how you can tell if a graph is the same as another. Now, there are more exercises. I can leave them and redraw them later, and I will post it again if you want to see it. Now, let's look at faces and trees. What do we mean by face? Let's do a little something fun. I will tell you. Do I want to tell you? Here, the face equals 1. Here, the face also equals to 1. Here, the face equals 2. And here, the face equals 2. Can you figure out why? Let's explore why. What is a face? A face is literally what it sounds like. If I were to draw a graph, this has a face of 2. Why is that? Let's do a different color here. This is one face, right? That is one area that the vertices and edges cover. Here is a different face. Of course, this goes on and on as far as the paper goes and as far as your brain goes. That was not meant to be an insult. Your brain can go very far. So, there are 2 faces in this graph because think of it as, say, a sheet of paper. You have oh wow, I did not know you could, okay. You have a face here, and you have another face here. So the face in total would equal to 2, because there's the area that's surrounded by vertices and edges, and the outside area surrounded by vertices and edges. Of course, it gets trickier from there, which I will talk about later, because I am not fitting all of this into one lesson. So that's what faces are. So, next thing we're going to talk about trees. What are trees? Trees are graphs with only one face. So, a tree could, say, literally look like a tree, like this, because there's only one face covering around this whole tree. And a tree could also look like, oh, wrong pen again. No, not the bright color. A tree could also look something like that. Why? Because the face also equals 1. Here, 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 here. That's a face. Face still only equals 1. Now, that's what trees are. So, now, we learn about what vertices edges are. We learn about degrees. We learn about how to differentiate different graphs. We learn about faces, and we learn about trees. Now, I will post some practice questions. I should write them down right now. I'll write them down so you guys can see if you guys actually understood the materials. Next time, we're going to learn about Euler's formula, and we're going to learn about the more things we could do with vertices and edges.